Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In the earlier sessions, we were talking about test of significance, large sample tests and small sample tests. In a small sample test, we have seen t test for testing the mean and f test for testing the variance. Also, we have discussed chi-square test for single variance testing and chi-square test for goodness of fit of various distributions. Chi-square test is also used for testing the independence of the attributes. The theory of attributes already we have seen in the earlier sessions that independence of attributes will be tested using chi-square test. That is what we are going to see in this session. The objective of this session is to work out some problems in chi-square test for independence. Procedures related to this is also discussed. This is the chi-square distribution table. We will be requiring this for extracting the table value of chi-square value. Now, what is the usual procedure for chi-square test for independence? The procedure is same as test for significance, only thing H0, H1 and the formula will differ. Chi-square test for independence, step 1, you set up H0 as similar to goodness of fit summation OI is equal to summation EI. Summation OI are the frequencies given in the question or observed in the case, and summation EI are the expected frequencies which we will be calculating using the contingency table. In words, we say that the two attributes are independent as far as H0 is concerned, and H1 we set up summation OI is not equal to summation EI, and we say that the attributes concerned are not independent. In step 3, a level of significance is fixed and degrees of freedom for test of independence is r minus 1 into c minus 1, where r is the number of rows and c is number of columns. And step 4 is usual procedure. Step 4 is the formula part, chi-square is equal to summation OI minus EI whole square by EI. And step 5 is conclusion part, comparison between calculated value and tabulated value, and then according to the comparison, if it is lesser, H0 is accepted. If it is both the values are greater, that is calculated value is greater than tabulated value, then H0 is rejected. Okay. So, in that sense H1 will be accepted, and then we draw the inference based on the comparison. Now, this is the contingency table of a 2 cross 2, that is 2 rows and 2 columns, where the OI table will be given in the question, or you have to frame it sometimes. OI table, OI is the observed frequency table, and then EI table has to be calculated using the formula row total into column total divided by grand total. Each cell stands for its corresponding row total into its corresponding column total divided by grand total. So, the test of independence, this is the contingency table and this is a 2 cross 2 table. Here one attribute will be given along rows and then another attribute will be given for columns. This is OI table. A is the number of values where it is possessing attribute 1 in a row and attribute 1 in column. Similarly, B is a number of values, it is the number of components possessing attribute A, attribute 1 along row and attribute 2 along columns. Okay. So, when this is formed, this is column total, row total, A plus B, A and B added together A plus B, and C plus D is C plus D, and the grand total is total of all totals A plus B plus C plus D. Okay. Now, with this 2 cross 2 contingency table, let us see how EI table is formed. EI table, when the number of rows and number of columns are 2 cross 2, accordingly you have to draw a 2 cross 2 table, 2 rows and 2 columns, and for this particular value of observed value of the frequency A, the corresponding EI value will be the A's row total is A plus B and A's column total is A plus C divided by grand total. So, the formula is row total into column total divided by grand total, which is what is the corresponding row total for A, EI table, A plus B into A plus C divided by A plus B plus C plus D, isn't it? Corresponding row total for A plus B, A is A plus B and the column total for A is A plus C. A plus B into A plus C divided by the grand total is A plus B plus C plus D. Similarly, for B, we have A plus B into B plus D divided by A plus B plus C plus D. Now, for C, corresponding to C, C plus D into A plus C divided by A plus B plus C plus D. For D, you have B plus D into C plus D divided by A plus B plus C plus D. Now, this is the 2 cross 2 EI table which we have calculated from the OI table. We will do work out this problem. A random sample of employees of a large company was selected and the employees were asked to complete a questionnaire. What are the questions asked in the questionnaire was, one question asked was whether the employees were in favor of the introduction of flexible working bonus. The following table classifies the employees by their response and gender, that is male and female. Test whether there is evidence of significant associate between the response and the gender. The question was posed to both genders, male and female employees. The question was whether they are interested in flexible working hours, and then we see the response was with respect to male in favor of the flexible working hours is 57 and female in favor of the flexible working hours is 83 and not in favor is 33 and 27. This is the OI table, observed frequency table given in the question. According to the number of responses, they are classified into two attributes, one is response, another one is gender. Now, the question is you have to verify whether there is a dependency between the response to the question and the gender. Now, let us go ahead with the testing the significance of the independence of attributes. So, first let us start with step 1. H naught says summation OI is equal to summation EI. That is, we mean that response is one attribute and gender is another attribute. Response and gender have no association, or no association in the sense they are independent, have no association with respect to the questionnaire, Okay. And step 2 is H1 summation OI is not equal to summation EI. It means they are dependent. Response and gender have association. Okay. And step 3 is level of significance. If it is not mentioned, let us take a level of significance as 5% and degrees of freedom is R minus 1 into C minus 1. Here number of rows is 2. So, 2 minus 1 into 2 minus 1 is equal to 1. Next step 4 is calculation of EI. That is we have to form EI table. EI table. EI table is also 2 cross 2. Okay. We just now look at OI table. This is the OI table, right, given in the question. We will put the total here itself instead of writing it again. So, the OI total you see 57 plus 83 is 140 and 33 plus 27 is 60 and this is 90 here and then 110. So, the grand total is 200, 140 plus 60 as well as 90 plus 110 gives you 200. Now, with this we shall form the EI table. What is the expected frequency corresponding to 57 is 140 into 90 divided by 200, isn't it? The expected frequency corresponding to 57 is 140 into 90 divided by 200 into 90 by 200. Similarly, corresponding to this cell, the expected frequency is 140 into 110 divided by 200. So, here the value is 63, here the value is 77 and similarly this is 60 into 90 by 200 is equal to 27 and this is 60 into 110 by 200 is equal to 33. Now, just look at the total. Here also the grand total should come to be equal to 200 because summation OI should be equal to summation EI. 63 plus 77 gives you 140 and similarly this is 60 and here you have 90 and this is 110. So, that grand total is 200. Now, we will list out the OI values and the corresponding EI values in a tabular column and then we will calculate chi-square. So, now this is calculation of chi-square. OI values given in the question is 57. You have to take the corresponding cell values. Corresponding 57 to 57, the calculated EI is 63. Similarly, corresponding to 83 given in the question, the calculated EI value is 77. Similarly, 33 and 27, 27 and 33. Just see summation OI is equal to summation EI, both are 200. Now, as usual procedure, OI minus EI is 57 minus 63, 57 minus 63 is minus 6 and then similarly this column is formed like OI minus EI, then correspondingly square that values, then OI minus EI whole square divided by EI. 36 by 63 is 0.57142 and then just add, this is your summation value, summation OI minus EI the whole square by EI. Now, that is the calculated chi-square value, right. We are in step 4. Okay. So, the calculated chi-square value is summation OI minus EI whole square by EI is equal to 3.463. Now, we have come to the comparison part. So, calculated chi-square at 5 percentage level of significance, 1 degrees of freedom is equal to modulus of 3.463 and then tabulated chi-square at 5 percentage, 1 degrees of freedom. Look at the tables for 5 percentage level of significance and 1 degrees of freedom, isn't it? This is the value 3.841. Okay, isn't it, for 1 degrees of freedom. This is 1 degrees of freedom. For 1 degrees of freedom, the corresponding chi-square value is at 0.05 is 3.841. 841. Just compare 3.463 is lesser than 3.841. Therefore, calculated chi-square is lesser than tabulated chi-square. Therefore, H naught is lesser than, H naught is accepted in the sense there is no association between gender and the response to the question. So, the conclusion is there is no association, which is the statement of H naught, right. There is no association between gender and the response to the question in the questionnaire regarding the flexible working hours. Next, if you are not given the OI table directly, you have to frame that OI table using the information given in the question. Next question is that type. In a survey of 200 boys, of which 75 are intelligent, 40 had skilled fathers, while 85 of the unintelligent boys had unskilled fathers. Do these figures support the hypothesis that skilled fathers have intelligent boys? Use chi-square test. Okay. So, we will use this information and form the OI table. Okay. So, totally 200 boys have been given, and the two attributes are, one is intelligence of boys, another one is skillness of the fathers. We will set up H naught, H1 etc., and then come to the calculation part, and then wherein there we will write down the OI table and then write down the EI calculation. Okay. So, step 1 is H naught says that summation OI is equal to summation EI, or it means that skillness of father is independent of the intelligence of the boys. So, step 2 is H1 summation OI is not equal to summation EI, and the skillness of fathers and intelligence, this is skillness of fathers, this is intelligence of boys, they are not independent. Okay. Step 3, level of significance, since it is not mentioned, we will have it as 5%. Degrees of freedom, just reserve it now according to the number of rows and columns which we are going to frame, we will calculate the degrees of freedom. So, OI table itself has to be calculated here. Skillness of father, and this is skilled father, and here you have unskilled father, right. And here rows heading is intelligence of boys, intelligence of boys. Intelligence of boys means intelligent boys and unintelligent boys. This has to be formed, these values has to be written, therefore, this is framed here. Now, the grand total is, total number of boys is 200. Okay. Just look at the question now, 200 boys, of which 75 are intelligent, 40 had skilled fathers, okay. 75 are intelligent, and among the intelligent boys 40 had skilled fathers. So, how will you extract this information, write it in the table? There are totally 75 intelligent boys. So, totally whether they are having skilled father and unskilled father, 75 are intelligent boys. Out of 75 intelligent boys, 40 had skilled father. So, 40 has to be written here. Now, you have to form the values here. Unskilled father will be 75 minus 40, this is 35, which you are just finding out using 75 minus 40. Now, next information given in the question is, while 85 of the unintelligent boys had unskilled fathers, that is unintelligent boys having unskilled fathers. Where does it comes? Unintelligent boys and unskilled fathers, this is 85. Okay. When this is 85, this total will be 35 plus 85 will be 120. When this is 120, I am just putting it in bracket because the bracket shows that you are calculating these values using the information given in the question. Okay, 120. Now, this is 120 and this total is 200. Therefore, this particular value here, that is skilled fathers total, will be 200 minus 120, which is 80. When this is 80 and intelligent boys skilled fathers, this cell is 40, means unintelligent boys will be 80 minus 40 is equal to 40. Now, just we have framed this tabular column. This is the tabular column formed. Skillness of fathers and intelligent of boys. So, intelligence of boys having skilled fathers 40, 40, unintelligent boys 40, having unskilled fathers 35 and 85. Total is 75, 125, 80, 120 and 200. This is actually OI table. Okay. Next is EI table. EI contingency table, 2 cross 2 table you have to form using row total into column total divided by grand total. What is that? Row total for this is 75 into 80 divided by 200. This value is 30, and similarly here you will be having 45 and 50, here it is 75. So, the total is again 75 and then 125, and here it will be 80 and 120. So, that grand total is 200. Now, list out these values in the tabular column. So, the values are 40, 35, 40, 85. EI values are 30. Correspondingly, you have to write. You should not write it in an erratic manner. Corresponding to the cell value, you should write it. So, 30, 45, 50, 75, this is 200, and usual procedure OI minus EI, and OI minus EI whole square is calculated, then OI minus EI the whole square by EI is calculated, and this total comes to be 8.88. This is actually summation OI minus EI whole square by EI. So, now therefore, of coming to the comparison part, writing calculated chi-square at 5 percentage, the degrees of freedom as mentioned, we have formed a 2 cross 2 table. Therefore, 2 rows and 2 columns. Therefore, 2 minus 1 into 2 minus 1, R minus 1 into C minus 1 is 1. Okay. So, degrees of freedom is 1 is equal to 8.88, and tabulated chi-square at 5 percentage, 1 degrees of freedom is equal to, same like the previous problem, tabulated value 3.841, calculated value is much higher than tabulated value. Therefore, H naught is rejected. H naught is rejected in the sense there is no association between intelligence of the boys and skillness of the fathers. That is the conclusion. That is, intelligence of boys and skillness of fathers are independent. In this session, some problems have been worked out in chi-square test for independence using the contingency table. The procedure related to this is also discussed. So, based on the discussion in this session, the following question may be posed: apply chi-square test to find out if the following figures provide evidence of the effectiveness of inoculations. Inoculated persons and attacked by a disease has been given. Attacked by a disease and inoculated is 20, and non-attacked is and inoculated is 300. So, the total is 320. This is OI table given in the question, and not inoculated is 80 by attacked, and not inoculated and not at all attacked are 600. So, the total is 680, and the row total and column total is given to you. Using the chi-square test for independence, you have to verify whether the inoculation of a particular drug is dependent or not dependent against the attacking of a particular disease. Okay. So, just to see whether there is any evidence of the effectiveness of inoculations. This is a 2 cross 2 table given to you, and using the contingency EI table calculate chi-square value and then find out whether the inoculation and inoculation have any effectiveness towards attacking the disease. Thank you.